Good morning, students. I think all of you fine. Previous class we discussed about matter around us, how the matter is diffused, and how the particles are exist, the space between them, how the molecular forces are acting between them. That we discussed in the last class. Okay. What is diffusion? So diffusion means the particles which are exist in it, they are moving in the air. So mixing of particles there and move from one place to another place is called as diffusion. Okay. And the examples we discussed about the diffusion. Okay. So in that one lab activity also is there. What is the lab activity? So HCl gas and ammonium gas both are react together. Then what happens there? They two reacted and they form a ring like structure. Okay. Last class I given for you. Okay. So diffusion we discussed last class, and just I introduced about that. Okay, diffusion. So in the lab activity, lab activity. What is the lab activity? So what are the materials required? What information you get obtained from the lab activity? I will explain now. Okay. So in the lab activity, we have to require first of all, what is our aim to lab activity? Diffusion of gases. Okay. So aim is diffusion of gases. So diffusion of two gases. This is the aim. So what materials requires? Materials. What materials require? So what are materials required? A tube, a long tube, 1 meter, a 1 meter long tube, comma, so what required? And cotton. And chemicals, what chemicals required? What are the chemicals required? So it is ammonia, comma, hydrochloric acid. Okay, should fabricate cork also. Okay, this is now. Okay, what is procedure is there? What procedure is there? What is the procedure? First of all, what you have to do first? Okay, so take a test tube, and so first of all we can take the solutions NH3 ammonia. So take ammonia in a test tube. Add some water to it. Why should we add water to it? To dilute. Okay. So water, and take next and HCl. Take HCl in a watch glass. Add some water. Watch glass. Add water to it for dilute. So don't take strong one. So you should add water to dilute. Okay. After that, what we do? So take a cotton and place a test tube on the stands. Okay. So next, place a test tube. Place a 1 meter long tube on the table. Okay. After that, what do you do? So take cotton. Take a cotton pieces and dip in a solutions. So in a NH3 solution, NH3 and HCl solutions. In HCl solutions. When after doing the solutions, then dip the pot in the solutions, and so place after that, keep the two cotton, place the cotton on the two edges two edges of tube, edges of test tube or pipe. Both edges open tube. It is a open tube. So like that, it is a open tube. Both sides should be open. Okay. So like this is open tube. Now cotton will be placed here. Cotton will be placed both sides. So now close this with a cord. The two edges close with by a cord. So now what happens? This is on the table. Okay. Now what happens when the cotton is placed both sides? It is placed in a ammonium and hydrochloric acid gases. So dip it in that and place the two ends of the test tube. What happens now? The gases are move faster. They are moving. So they are moving here together. So it is a HCl. It is ammonia. Okay. What happens? They move together. And then after what happens? They travel faster. Sometime what happens? They are diffused together. They are mixed together. Then they form a ring. Where they diffuse, there they form a ring. Where the ring is formed, there it will diffusion takes place. The ring we obtain, the ring is formed near to the hydrochloric acid gas. Means ammonia gas is travel faster than the HCl gas, then diffuse together. So this what is the result obtained? A ring is formed nearby the HCl. The diffusion takes place between them. So the ring is the result. The ring is not formed. How can we know? They are diffused. So ring is the result obtained when the ring is formed only is correct results. So when the ring is obtained, there the diffusion takes place and the ring is formed. Okay. Now the result is, so the diffusion takes place between the two gases and ammonia gas travel faster than the HCl gas. So this is like that you can write the information. They ask the question. So explain how can you explain a lab activity on a diffusion of two gases? Means to explain this information. Okay. Next step. So how the particles are arranged in a, how does the particles are arranged in a substances? In a substance, you know all of you. The space is exist between the two particles. The space is exist. How does space exist? You know, how can you know? The space is present between the two molecules in a substance, in a matter. So that is very simple. So we have, so the space is present between the molecules. Between the molecules of matter. Molecules of matter. So any matter we can take. How many types of matters are there? We have there are three types of matter: solids, liquids, and gases. Okay. So for that we can activity obtain. So now take a beaker and add take a beaker and place. So in any beaker fill, take a beaker and add some water. So up to half of the water, fill with half of the water. So this is a beaker. So in that we can add some water. Up to here we can add some water. So when you add the water, after adding water here, now after some time add some in water, add some 5 spoons. Okay, some 5 spoons of salt or sugar to it. Sugar to the water to it. What happens? What you observe when you add for example, when you are drinking a tea, if you pour some sugar to it. So without sugar you can't drink tea, no? So we can add some sugar to the tea. So what happens to the tea? So what we observe the level of the water after adding salt. Add salt. What we observe the level of the water level decreased or increased? The water level is increased up to here up 10. So initially, so V1 and V2. So V1 initially without adding water, after adding salt to V2 level. So what happens? Somewhat water level is raised. So why the water level is raised? Because we are adding some salt to it. So where the salt is goes down, so the salt will go inside the water molecules, and there is a space between the water molecules. There is a space between the water molecules there. So these are the space present between them. Then the salt particles go and fill this space. Fill the space. So that's why the salt does not obtain, does not conceal in the. That's why they dissolve and they go and fill the space between the particles. Then that's why the water level will be increased. So the space between the particles can be closed. It can be filled by using a. So what we are adding, the dissolve means the water level will be. So from this experiment we know that the space between the particles will be present, that we can fill by using adding some material to it. That's why the level of the water will be increased. So this is the activity which explains about the space present between the particles. And also we know a few. So diagrammatically you can explain how the molecules are atom present in a states of matter. There are also questions. Okay. So for that we know all of you, it is a solid. It is a solid. For example, solid. How the molecules are present in the solid? So inside, so the solid will present there. We can explain by using a. So draw this. So the molecules are present like this. To draw the diagram, explain for the molecular element of particles in a solids. Okay, in solids. So like this, you can draw the particles present in a. Draw the diagram. Very important diagram. And how can you draw the diagram? How can you explain the diagrammatically? The molecular element of matter. This solid. Okay, this is a solid. Okay, next liquids. How does the molecule present in a liquid? Okay, so liquids. So in the liquid, we can write. So in a liquid, how the molecules are present? Can explain by using this. So there is some space present in the molecules. There should be some gap. There should be some gap between the molecular element of these molecules. Okay. So this is next gas. So this is a gas. So gas. So in the gas, you can draw the diagram like this. So the particles present there. So like very free. They are very free. The diffusion rate of diffusion high for gases only because of they are move faster. The speed of the particles move faster, and also the space present between the particles will be very high. That's why the rate of diffusion of gas is very high. And also liquids have some gas present. They are movable. They are movable from one place to another place. That's why the rate of diffusion also somewhat more compared to solids, more for liquids. But here compared how they stronger, how the stronger force present between them. See, that's why they are very stronger. That's why there is no diffusion taking place for the solids. So like that, the molecule will be arrangement of molecules in a solids, liquids, and gases. They ask the question about explain diagrammatically how the molecular arrangement of atoms present in a states of matter, solids or liquids and gases. So explain means you should draw this diagram and explain the molecular arrangement. This is about the states of matter. Explain. So next step. So friends, so you should draw the diagram. Practice at home, all of you. This diagram, very important diagram. So you will get in exams also. Okay, now attraction between the molecules. Next activity. So attraction. attraction between the molecules, between the molecules of matter, molecules of matter. So attraction between the molecules of matter. Okay. So how the molecular arrangement already I told you. How the molecular arrangement will be there. So for example, if you hit the odd solid substance, they are not break down. Okay. So that enough force not applied means they not break down. Okay. Sometimes, for example, iron rod is there. For apply force with your hand, is break easily? No, they should not be possible because they have very high intermolecular force present between them. Very strong force between present them. That's why they are very strong. For example, so in a tap, the water is coming from a tap. So the tap, so on the tap, so the water is present. Water is coming. So whenever you can place a finger there, place finger. What happens when you place a finger? It will be cut. Okay, it will be right on there. So again, what happens when you take out finger? That will be attached again. They will be attached. They will continuously moving. So whenever you place a finger, they will break down. Immediately what happens is, immediately it will be attraction together. So there will be, the molecules will be attract each other because, so whenever you place the finger, it will break down. Again leave the finger, it will be flow continuously. So the liquids are flowing, and they are having the attractive nature. So whenever the gas is present here, so when you wave your hand, it will spread. Again after some again they fill the area because the molecules having the molecular attraction forces. Because of that, they are move continuously. Okay. So that's why by this activity we can explain. A tap, you know, at home we have taps. Observe it. Students observe that in place whenever tap release the tap, the water is flowing down because of gravity. Okay. When you have finger there, so it will be observe that it will break down. Again, what happens? It will move continuously. So because of molecular attraction force present between the atoms together. So next we have the change of states. So already we have solids, liquids and gaseous states there. Okay, in that we can explain that so how the matter will be changed from state to and solid to liquids, liquid to gas. Sometimes it may be changed from solid to gas also. How it is happen? How it is happen from changing from solid to liquids, liquid to gas, and also by changing some conditions we can change from gas to liquid, liquid to solid. Okay, so sometimes we can may change from solid to gas also. How it is happen? We can explain this. Okay, so okay, changes of states. Changes of states. Okay, you know, we all of you, how many states we have? Solids, liquids, gases. Solids, liquids, gases. Okay, so solid. So by increasing temperature or decreasing temperature, there is a chance to change the state. For example, solid, there is a chance to change from solid to liquid. Okay, there is change from liquid to gas. There is chance gases may be changed to. There is chance to gas change to liquid also. So liquid, there is chance to change to liquid to solid. Liquid to solid. There is chance from solid to gas. So sometimes the matter may change solid to liquid, liquid to gas, gas to liquid, liquid to solid, solid to gas. Is there any conversions? Solid to liquid, there is chance to change. So liquid to gas. So again gas to liquid. liquid to solid, solid to gas. Okay, so these two are reverse, solid to liquid, liquid to solid. These two, gas, liquid to gas, gas to liquid, solid to gas. Okay, solid to liquid, what we call it is, so the substance changes status. The solid state converted into liquid state, what we call it is a melting. Is a melting. Okay, and liquid to gas is called, what we call this is, what we called boiling. It's called boiling. Okay. Next, gas to liquid is called condensation. It's called condensation. Okay. Solid to liquid, liquid to solid is freezing. Is freezing. Solid to gas directly, solid to gas is called as a sublimation. It's called sublimation. Okay. Already these all information I given in last previous classes in physics. Okay. Solid to liquid, melting. Liquid to gas, boiling. Gas to liquid, condensation. Liquid to solid, freezing. Solid to gas is a sublimation. Yes, I given or not information? Yes, I given. Okay. So we observed in our home, at home, when you are taking a water bottle at summer season. In summer season, we observed that. So we kept a water bottle in a deep refrigerator, freezes. So after 1 or 2 hours, what you observed? What you observed? So the bottle of water becomes a hot, becomes a solid state. Because it becomes a solid. Why it becomes solid? Because why it is solid change into solid? So that is the best example. It is a decrease in the temperature of the substance. We can cool down. Then what happens? Water is a liquid state. Convert them into solid state. Okay. So best example is water converted into ice. Okay, or first of all, so ice converted into water converted into water vapor. So what ice is state, ice is a solid state. It is solid. Water is a liquid. It is a gaseous state. Okay. Ice is a solid state. Water is a liquid state. Water vapor is a gaseous state. So solid converted into liquid converted into gas. The best example now, see in our home only you are observing this. This is a natural. So natural way occurring this all those things. So ice, water and vapor. So ice, when you take ice and keep in your palm. So why that ice melt? Why the wow? So what is the reason for melting of ice? Our body temperature. The temperature is observed by the ice cube from our body and melt. So the melting ice melt and becomes water. So water again converted into water vapor. Okay. So next class I will explain you about why the changes of matter will be occurred. Why the changes of matter will be occurred, and what are the melting point and boiling points, and what is condensation point, what is freezing point, why the sublimation will be occurs, and all those things, why it will happen. That all those things we discuss about that, and next class I will explain about it. Okay. So today's question. So homework questions I will give and write about it. Okay. Explain lab activity. Explain how the gas diffusion takes place. So homework. So explain how does the gas diffusion takes place. Okay. So gas diffusion, I explain lab activity, nothing but lab activity. Lab activity. This is a lab activity question. Everyone should write about this. And also, while you are watching a video, keep your textbook with you and listen 2 or 3 times. 2 to 3 times listen. Carefully listen. And also, while you are watching this video, you can keep headset. You can listen clearly. And also, textbook. Go to the textbook. What is the lesson? I explain it. Okay. So, in one more class will be there for you to complete this lesson. After completing the lesson, once you go through the lesson, what question they are asking, how the question they are asking, and how can you write the answer. So when you are reading the textbook, you will get the answers for the questions. Okay, what we learned, we have the key words will be there. Read the keywords and question answers. Read the question answers. Okay, very easy questions will be there, and that answer also will be maximum 90% answers will be there in the textbook itself in the lesson. Okay, so everyone, I think you'll go to the textbook and read that question answers, and now you can write the answer for this question. Okay, so thank you, friends. Thank you.